Okay, so what we're doing today is combining like terms, all right? But this time our terms have square roots or cube roots or radical expressions. That's what they say, okay? So as long as they're the same, all right, you can add them, meaning that index, you might not remember what that is, but that little number, if they're both square roots, you can add them. If they're both cube roots, you can add them or subtract, okay? Everybody's got that? Yes. So the number that's on the outside is what you add or subtract. Whatever's on the inside of the root, underneath the root, it stays that, okay? So it's like if I have 2 square roots of x and I add another square root of x, how many do I have? 3 square root of x. Does that make sense? Yes. So we're not multiplying because we did that actually first. So here's your first problem. See, I told you were just adding and subtracting today. That's what you asked for. So our first one says, okay, 3 times the square root of 5x minus 2 square root of 5x. Do they match? And it's not just the square root, but the actual 5x and 5x. Okay, so what's 3 minus 2? 1 square root of 5x. You can put the 1 if you want to, but I usually don't write the understood one. Yeah.
3 minus 2 square root of 4x. Do you do 3 square root of 2x? You simplify it, right?
Yeah, because the 3 wouldn't have anything with it, right? Is that what you're saying?
Oh, are you talking about like 3? Okay, read me the problem.
3 square root of 4, no, 2x.
Square root of 2x.
Minus 2 square root of 2x.
Same thing. It's just going to be 1 square root of 2x.
Okay, I did that wrong. Say those 2's are 4's.
So we'll get to simplifying later. It might be that we have to simplify something. It actually will be. Okay, but we'll get to that. That'll be like our next step. Okay, so what about if I have 6x squared, and that's an x squared, okay? And then I have 4x squared of 5. Can I combine these? No. One's a square root of 7 and one's a square root of 5. See how they don't match?
What about the x?
Well, the x is like,
So,
the
square root matches, you can
yeah, only if the root matches, okay? We'll see about something like that later.
If the number underneath the square root matches, or like the x.
The end, all of it. So, being that both of these are square roots, but they also both have to be
So that
the
one-
same.
If that one over there on the right was as also square root of 7.
Then I could have done something with it. Yes, I could have.
I thought you can't add like an x squared and an x.
You couldn't. So I would have, if they would have been this, it would have been weird. Okay, so this one you can't do. They put can't combine. All right, so couldn't do that one. But if they were like this, can you combine 6x squared and 4x? We'll just have to write it like this. That's weird though. I'm probably not gonna give you one like that. But I could combine them because the roots are the same. Square root of 7, square root of 7. Okay? So what we already learned, multiplying, I could multiply square root of 7 times the square root of 5. But I cannot add them. It's like I can multiply x squared times x. But can I add x squared and x? No. So same kind of idea. All right. Let's do another one. It says 12 cube root of 7xy minus 8 fifth root of 7xy. Can't do that. Why?
Because the cubes aren't.
The cube and the fifth root are not the same. The whole thing right here has to be the same. Okay? So is everybody good with that? That's just our first thing is being able to tell. Do y'all want to look at the ones from the worksheet?
I thought we were doing the worksheet.
Y'all want to do the
Can you
worksheet?
give us the worksheet? Okay.
I was just going to go over the worksheet with y'all
Yeah,
today.
Yeah, it's just.
Yeah, like I was just going to make sure we have all of our examples so we don't miss anything. Okay, and it was all going to be multiple choice. On this top one, can we combine those? Yes, so what would it be? 8 fourth root of 2x. It is C.
C.
Does everybody understand why it's C? See how they throw some in there to confuse you? But if I'm adding fourth roots of 2x, I'm going to have fourth root of 2x. There's going to be 8 of them. Everybody's good? All right, the next one, can we combine those? No, that's not possible. They are both cube roots, but then they're different. One's a 3x, one's a 10x. Can't do that. All right, can we do number 3? Yeah, they both match, and so it's -3 square root of 2a. Everybody's good with that? It was C.
Sorry, I'm trying to get my right real quick. I forgot.
Okay. Now let's see our next problem. They talk about a perimeter. We'll just do this one. A perimeter. What does that mean for a perimeter?
Like the outside.
Yeah, you add up the outside. So it says a width of square root of 13, a length of 7 square root of 13. What's the perimeter? Now, how many widths and how many lengths are there? Okay, there's 4, but there's 2 lengths and there's 2 widths. So what you would have is there's 2 different ways you could write this. That's what I would do. Some of you might say, I have a square root of 13 and another one. And then how many of these would I write? 2 of those. 7 and 7. And I would add all those up. But wait just a second. Let me show you how I would have done that. I would have said, I have 2 of these and 2 of these. Where did I get 14 from? 2 times 7. Okay, so either way, I don't care what way your mind thinks, okay, on that. Just figure out which one looks easier, and then we'll combine them. So what's 1 and 1 and 7 and 7? So up here you would get 16 square roots of 13, and down here you would also get 16 square root of 13.
Ms. Texas, Ms. Bradley, please admit Georgia and Tanner to check account.
Yes, ma'am.
Man, everyone's just on Alexa's book.
See, you are all here. All right, everybody's good with number 4? Yeah? Questions? No?
The service is crap.
All right. Let's see the next one. I want to see if I want to do this one yet or not yet. I think we'll come back to this one. It might be the last problem for the day. So let me move on to our next type of problem. Georgia, real quick, we'll do these 2 with you, just so you can see what we've done. All right, we're kind of just going through our worksheet together for today. So you can add these 2 only because the square root of 6x and the square root of 6x, they match. So what's 3 plus 5? 8. So my answer would be 8 square roots of 6x. That's all, pretty much all we've done. On this one, do they match exactly? Yes, I'm looking at 4th roots of 6a, and then what's 6 minus 4? I've got 2 of those. Okay, that's it. If they don't match, then you can't add them. Meaning, if that said 3 square root of 5x plus 2 square root of 6x, can you add that? No. All right. And then the same thing, like this number also has to match. Okay? All right. Last type of problem, and then we'll do the word problem.
What is the student?
Well, and then we'll do that last word problem, huh?
What is the student's Wi-Fi?
I don't know.
Whatever.
All right.
Yeah,
Let me move my book back. Okay, I've got square root of 12 plus the square root of 75 minus the square root of 3. Can you add these?
No.
They have to match, right? That's what we just said. Now, on these problems, it says simplify, then combine like terms. So this is what you were talking about at the very beginning, like what if that can be simplified under there? Well, now that's going to tell us simplify, then add or subtract. All right? Are y'all warm in here? Or are y'all good? We're good. Leave it on for a minute? Okay. Now, what is a perfect square that goes into 12? 4 and 3. And y'all look, real quick, a big hint. Make sure you're paying attention up here. Big hint. if you're trying to combine these like terms, which one of those is the smallest number? All of those should have a 3. Okay? All of those are going to go to a 3. So like you just said, this is 4 times 3. Notice our 3's in there. What's the next one going to be? What's 75?
25.
Times 25 times 3. And then this one has a 3, huh?
Wouldn't you just do 5 times 3?
But you can go.
Yeah, so now we'll take the square
we have
roots.
to take it out.
Yeah, now we take the square root, and what are they all going to have underneath the root?
3.
A 3. Okay, we're adding one extra step. So what's the square root of 4? 2. There's my square root of 3. What's the square root of 25? It's 5. Leave my square root of 3. Square root of 3. Can we combine them? So 2 plus 5 is 7 minus 1. There's 6 square root of 3. Okay? So, it's just taking what we've already learned. All right, you just simplify it, and then you can add or subtract them. And some of you can probably skip from this step to this step. That's fine if you can. But I write everything out. Let's do another one, and then we'll look at our paper. No, I don't like that one. Let's see. I'm trying to find one. Okay, here we go. That's the same number. Square root of, this one doesn't give us a hint. Square root of 72 plus the square root of 32 plus the square root of 18. A lot of times they'll kind of be able to look and see what number's underneath it. But on this one, I can simplify all of those, right? So what goes into 72? 9 and 8, okay. Well, that's not the biggest number that goes into 72.
18.
Look up there under our square roots. What times what? It's a bigger number than 9. So
16.
16?
it's 36. Okay?
Was that 36
Right.
and 2?
Did I say that right?
36 and 2.
Yeah. 36 and 2. And then for our 32, what's that one going to be? 16 and 2. And what's our 18 going to be? 9 and 2. Do y'all see the pattern? Yeah? Okay. So what's the square root of 36? 6 square root of 2. What's the square root of 16? 4 square root of 2. And what's the square root of 9? There we go. Add them all together, and what is it? 13 square root of 2.
You just gotta use your brain on this tower.
Yeah, so, but a lot of them, oh, I'm sorry, y'all, I could have lowered that earlier. Let's look at our paper. Let's see what they have. We are almost done, and we've got these 3 problems, and then we'll do our word problem. I'll look at it for a second. Okay, so this one on number 6, we can tell what number is going to be under the square root. What's it going to be? 5. Okay, so what is my square root of 20 changed to? 4 times 5. And what's my square root of 45 changed to? 9 times 5. And then there's that one already done. So what this one is going to be what? 2 square root of 5 plus 3 square root of 5 minus 1 square root of 5. Which is what answer?
4 square root of 5.
It's A. 4 square root of 5. These aren't so bad.
It's probably the easiest thing like we did.
It's just like the best whoever.
Okay, this one, what's going to be under the square root? You should already tell. When it's a small number like that it can't be like reduced in a sense, it's going to be 2. So the 18 is 9 times 2. The 50 is 25 times 2. And then here's our 2, square root of 2. So what's the square root of 9?
3 square root of 2.
There we go. What's the square root of 25? And minus the 1 square root of 2. So what is that going to be? They're all A. 7 square root of 2. Oh my goodness. At the next one. It's fine.
Can we just get it?
No. Just start with the smallest number. Once we figure out the smallest number, then we know the rest of
I
them.
think it's A.
Okay? Then we'll know. So let me erase this and move this up.
Wait, is it going to multiply by 6 and stuff?
Well, let's see. What goes into 48? A perfect square that goes into 48. 16 and 3. That means, I'm thinking, okay, so, oh wait, these are cube roots. I'm sorry, these are cube roots. What cube root goes into 48? 8. So that's going to be 8 times 6. So all these are going to have a 6 left underneath, okay, if they can be simplified. And look, you can look at your answer choices. So just divide that by 6. What is 2,058 divided by 6? I have no idea. I just know that it's something times 6. So y'all are going to make me get the calculator out. Okay. Y'all are lazy. 2,058 divided by 6. It's 343. And that is a perfect cube. Does anybody know it? 7.
It's 7. You did like the answer.
It's 7. Okay. Then this one, what times 6 is 750? So I'm going to do 750 divided by 6. And it is 125. Does everybody understand how I knew it was going to be a 6 underneath once I found this one?
The answer.
Yeah. And the answers also have a 6. So what's the cube root of 8? 2. Cube root of 6. What's the cube root of 343? 7 cube root of 6. And what's the cube root of 125? 5 cube root of 6. Now we can combine them, and what do we get? It's A again.
I said it was A. I said that. I didn't have to do it.
Okay, that was our last problem other than our word problem. How's this? Easy, so easy. We should have just done both lessons today.
No.
Okay. Hold on, let me get the word problem out. Okay. I might need to, let me see. Pause for a second. Okay, so, let's first simplify. What is the square root of 150? So, the square root of 150 is what times what? Look at our perfect squares. It is, 25 times 6. So this is making sense that it's going to have the 6 underneath, right? Well, what's the square root of 25? 5 square root of 6. Now, I want you to think that I have this row, okay? And they split it into, they've got 2 to 3 ratio. See, this one's a little bit longer. Now, think of that in terms of 5. If I have 2 square roots of 6 over here, how many do I have over there?
Wait, you just start at 2.
Yeah.
You would have
3. Because it says, what's the length of the longer piece? 3 square roots of 6. Anyway, that's how my mind. But let me start over. There's maybe an easier way to do this. But I was thinking, okay, let me first simplify. 5 square root of 6. So I have a row, okay?
Well, where did you get that from?
5 square root of 6. Oh, the square root of 150 is 25, the square root of 25 times 6. I simplified it, okay? So I get 5 square root of 6. Now, let's look at this row. And they want me to cut it into 2 pieces. I'm going to cut it right here, where we're going to say this is 2 or whatever to a 3 ratio. Now look at the number 5. This side is 2. This side is what? 3. Doesn't that add up to 5? But it's, so I'm thinking this side is my 2 square root of 6. This side is my 3 squares. What's the longer side? 3 square root of 6. Okay? That one's kind of weird.
Yeah.
Are we done?
Oh my gosh, are we done?
Hallelujah.
I said word.
That